It can be used to power a sensor device. It can be used to recharge a battery, a rechargeable battery. But the point is we can send that RF energy over the air, capture it, and then do stuff with it. So that's like true wireless in the same way that you would think of like Wi-Fi or Bluetooth as being wireless.
Hi, everyone. Welcome to the Sustainable Supply Chain Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Eric. Eric, welcome to the podcast. Would you like to introduce yourself?
I'd love to. And first of all, Tom, appreciate you having me on here. This should be fun, and I've been looking forward to it since I heard about it. So I'm Eric Biel, and I am the Director of Strategic Partnerships here at Powercast. I've been in this role for a few years now, but I've been with Powercast for, I like to say too long, but it's going on just over 12 years now, working on wireless power things, including RAIN RFID that supports supply chain and sustainability and all that fun stuff.
Okay, so Eric, you mentioned Powercast and wireless. So give me a little bit more detail on what Powercast is and what it has to do with wireless.
Absolutely. So Powercast is a wireless power company, and we sort of have three legs to the stool as we describe it for those wireless power options. The first leg of the stool I described is basically what most folks are familiar with. So if you have a cell phone these days, it basically will probably have Qi-based charging in it. So that is a inductive based charging mechanism. There's a coil on the phone side, there's a coil on the transmitter side. You set the two devices together and off you go. You're charging your device, quote unquote, wirelessly. There's pros and cons to that. Obviously, it's technically wireless charging, but you have effectively no range, but you are transferring a great deal of power. Standard now is about 13 watts. The second leg is probably what we're most known for, which is radio frequency RF based far field charging. So the concept there is very cool. Basically, you have a transmitting device that sends out RF energy into the air. Same thing happens when you make a cell phone call. Your Wi-Fi router does this, right? There's energy in these radio frequency signals that are going out into the air. And what we do is we make a semiconductor chip, and along with an antenna, we capture some of that RF energy that's going out there, and the chip efficiently converts that into DC power. And that DC power can be used to do any number of things. It can be used to power a sensor device. It can be used to recharge a battery, a rechargeable battery. But the point is we can send that RF energy over the air, capture it, and then do stuff with it. So that's like true wireless in the same way that you would think of like Wi-Fi or Bluetooth as being wireless. And the ranges are pretty significant. The farthest we've ever gone is about 120 feet. The amount of power you get is going to be dependent on how far you are from an emitting source. That 120 feet, you're looking at like very low levels of microwatts of available power. So that was a low duty cycle sensor operation. Wake up, take a temperature sensor measurement, blast a Bluetooth packet out, go back to sleep. And it would do that like once a minute or so. But the point is like I have a completely passive device sitting way over here, and I'm able to provide power to that thing wirelessly. So we dabble in that, and that's integrating our technology into our customers' products, working with other folks to design antennas for them, putting all these things together, and in some instances, even doing full product design for folks where we take over all of their electronics, their supply chain, their packaging, everything. So we kind of have a full stop shop on electronic product design. And then the third leg of the stool is something we've recently added. We debuted it at CES 2025 in early January this year, and it's magnetic resonance recharging. So the way I like to think of magnetic resonance is sort of a bridged gap between the previous two legs of the sort of Qi-based inductive and the far field RF, where it's still a coil to coil type of charging mechanism, but you get much greater freedom of placement of the receiver devices. And you actually get Z separation as well, all the while still transferring up like significant amounts of power in the upwards of 100 watts of power. So the example we showed at CES this year was basically a desk. Imagine your desk. You have a coil basically sitting under your desk. That's your charging coil. And then all the devices that sit on your desk, including your laptop, the monitor, the keyboard, the mouse, your phone that's sitting there, all of those had receiver coils built into them, and you could set them anywhere on your desk, slide them around. There's no, I have to set it on this pad in a correct orientation. And all of those devices were simultaneously being powered and able to be charged. Those are the sort of three legs of the wireless power stool that we build here, and then we implement this into our customers' products. Anyone who wants to enable wireless power comes to us as sort of it's generic to say, but the one-stop shop of wireless power. Going along with that, not only are we involved in supply chain, just in the inherent nature of our electronics business and the sourcing of our own chips, but we manage these supply chains for our customers too. And we leverage RAIN RFID in those markets to support not only our own products for tracking, but then there's more things we can add on top of it with wireless power technology that I'm sure we'll talk about in a little bit here.
Sure. I'm just thinking as you're saying this, that the people who do stock photography must love this idea, because anytime you see stock photos of offices, you have monitors, you have keyboards, you have zero cables. The monitors are working with zero cables. Yep. So,
well, yeah, and it's sort of like if you've ever looked for a house and you see some of the stock photography or the photos they use they make it look very good, right? And one caveat with Powercast is there's some other folks that do wireless power stuff, and a lot of sort of the messaging is a little futuristic. I like to think, as far as Powercast goes, I like to think we're very upfront about what the technology can offer, what it can do, but maybe even more importantly, sometimes what it can't do. So if you come to me and you said, I want to power my blender across a football field, can it be done? Technically, yes. It's not a limit of the technology, but from a regulatory and a safety perspective, yeah, we're not going to do that kind of thing. The number one question folks seem to give us, well, I guess there's two questions we get the most at when we attend trade shows or we're doing media or anything like that. The number one question is, can you charge my cell phone? And the answer is, yeah, of course. We can do it with the Qi stuff. Of course, everyone can do that. But can we do it, through the air while I'm walking around with it and all that stuff? And the answer is yes. But given the limits put on us, just like other devices are subject to, like Wi-Fi routers, there's a limit to the amount of power we're allowed to put out, which inherently limits how much power we're ultimately able to receive. Can I charge the phone wirelessly through the air? Yes, but it's going to take a significant amount of time to the point where it's probably not going to be a great user experience. So sometimes you see those stock photos of, oh, I'm just carrying my phone around and it's just automatically being charged. I walk into the coffee shop and then I walk into my home and it's just automatic and I don't have to think about it. That's a little far-fetched, but it is technically possible. So that's the first question I always get. And the second one is, given those things I brought up about, power level and safety, they're always asking, well, is this a safe technology? And I give them the same answer. If you're comfortable using a cell phone, holding it to your head, answering calls, our technology is orders of magnitude lower in terms of exposure, given the way we use the technology and that it's not next to your body or your head most of the time. This is like basically nothing compared to what you'd get from holding a cell phone there next to your head. So I like to think it's safe. Like I said, I've been doing this coming up on 13 years. I'm fine. I know, anecdotal, but also we're subject to the same regulations as every other device that's out there in the world too. So no big deal as far as that's concerned.
Sure. And who would be Powercast's customers and what problems are you solving for them?
Given that we're basically a power source, power is maybe the broadest possible market for electronics, right? Every single device that's out there, outside of some RAIN RFID tags, which we'll talk about, it pretty much needs a battery or a power source of some kind, right? So our competition is sometimes a wall wart and a wire. With the rise of the IoT, basically things that are out there, anything that has a small battery is a potential candidate to use wireless power. Some of our biggest customer that we can talk about is Samsung. So if you buy a Samsung television, they have their Eco remote that comes with it. And they had this was 2 years ago, they had a large green initiative. They wanted to eliminate the alkaline battery waste of batteries cycling through their remote controls, which they're a massive company. They're selling millions and millions of TVs. That's millions and millions of batteries cycled through once a year, whatever it is. So they wanted to eliminate that waste. So their Eco remote removed batteries from the remote control and opted for basically a supercapacitor in its place. And so there were 3 methods you could use to charge that remote control. It had a USB-C port, so if you needed immediate charging right now, you could plug the thing in. There was a solar cell on the back of the remote, so sunlight and ambient light could be used to top that supercapacitor off. But the most interesting is that our chips are in there with an antenna, and we harvest ambient Wi-Fi and Bluetooth energy and use whatever is available to top off the supercapacitor. So if you're within, signal strength that's large enough to charge that thing, we're going to take that energy, we're going to convert it to DC and top that supercapacitor off. It's out there in huge quantities, but most people don't even know it's there. But huge deployment there in the consumer electronics business. Powercast is coming up on 23 years or so in business, which surprises a lot of folks when they think of the wireless power stuff as being extremely futuristic, right? It's Nikola Tesla, and they're 100% right. So they're surprised that they haven't heard of it before. But we've been doing industrial and commercial sensing, since as early as 2007, 2009. So we've had products out there for a significant amount of time. They're just not the most sexy applications all the time. A temperature sensor sitting in the back of a warehouse building, monitoring that for HVAC reporting, or a light level sensor, again, in an industrial warehouse, is not the most attractive, flashy headline to pull people in. But that's what we've been doing, right, for the longest time.
Okay. How does the cost of a sensor with one of your chips in it compare to the cost of a sensor that you can power with a battery?
Good question. So obviously adding more things to the device will likely increase the cost, and that's no exception with our technology. So you'll have a change from basically a primary non-rechargeable battery to a rechargeable battery. Inherent in that, you're going to almost always get a reduction in the capacity of that battery, so it will last less long. But now you have the opportunity to recharge that battery. So you have a smaller upfront cost, definitely, in terms of the device itself. Additionally, you need a source for the wireless power. In most instances, you need a transmitter of some kind, and we make transmitters that act as sources of RF energy. Other sources of RF energy could be RFID readers. So if you have them in your warehouse, that can be an inherent source of RF energy that we can harvest to dump these things out. The real value, though, comes in from downtime, maintenance, and things like that. So if you have a battery powered sensor you're relying on for, temperature automation in a warehouse, for example, it talks to your building automation system and your HVAC to control a temperature in a given section, and that dies for whatever reason. Now you're not only losing the ability to control that piece of the building, you have maybe incurred additional heating costs, whatnot. But if you want to replace that, you have to roll a truck. You're sending a person out to change batteries or to literally throw the device away. There's e-waste associated with that, and having to rehook that system up. So there's an incredible cost associated with that. Imagine if you had hundreds of these in a deployed space. That's a significant pain point. With the wirelessly rechargeable nature now, you literally never roll the truck. The cost is incurred up front with, the extra cost incurred from our chip, which in volume is sub $1 for that chip. You've got the transmitter systems, or you can leverage existing ones. Again, a lot of warehouse places have RFID systems in them that can be used, but you're eliminating all that additional labor overhead and lost operating time that you might incur, the headaches really down the road.
You're also, I got to think, eliminating e-waste, because lithium-ion batteries today aren't recycled as much as they could or should be.
Correct. Yeah, that's definitely true.
A lot of that has to do with the form factor. If you have lithium-ion batteries in something like a car, they're easy to get to, easy to pull out relatively, because they're big and easy to recycle. And there are companies who are doing that. But lithium-ion batteries in something small like a sensor, much, much harder to extricate and recycle. So I got to think there's an e-waste problem there that your solution is addressing, right?
Absolutely. For several reasons. I mean, right off the bat, just the inherent nature of recharging means you're eliminating the disposable batteries. So not from the lithium aspect, but just the battery e-waste in general, right? Which is massive. So you have that devices that are single use that might run, even a device that's designed to run several years on a single battery is still going to end up as e-waste. Whereas if that system is reliable and rechargeable, then that's a lifetime style device that could last 20 years or more, right? So you're picking that up as well. But then you're 100% right on the lithium battery side, where that's a ton of waste that people aren't thinking about as much. Cars are easy, right? EVs
Mm.
are easy because the batteries are so significant to the whole thing. But phones and all these other small children's toys that have these rechargeable batteries in them, they all just end up as waste too. So with wireless power, by extending lifetime, you're inherently reducing e-waste is sort of one of the tenets we kind of look at when we're talking about adding wireless power to something.
Okay. And this has implications as well for things like regulations, correct? Because I know, for example, here in Europe, we've got this digital product passport legislation coming on board, and this impacts that, right?
Right. And I'm not sure what the listeners might know about the digital product passport. It's relatively new to me. Obviously, Powercast is based in the United States, but we keep our eye on what's happening in the world, basically, because you kind of have to think globally at this point. The digital product passport is an extremely interesting concept. It's sort of a necessary tag or document that accompanies a product through its entire life. It's attached to the device in some way, and the information included on the thing is kind of vast. Information about the material sourcing, what's in the device, the material composition, where it came from, where it was made, any repair history for the device, disassembly, and then maybe instructions on how to recycle that
Hmm.
device appropriately. And this digital product passport might take the form of a QR code. It might take the form of an NFC tag, or it might take the form of a RAIN RFID label. Each one has some pros and cons to it. QR codes are great. They're cheap and easy. You can scan them with the phone. But if it's on maybe like a piece of clothing and you're washing that thing, that QR code's going to be gone, right? If it's something that's outside, again, sun is going to just, the UV is just going to destroy that QR code. So there's kind of challenges with that. NFC is a great option. That's in most phones now too, but you have to be right up on the thing to read it. It's inherently a near field
Hmm.
technology, but you can store data on it. But the interesting one that's used the most in supply chains, and I think has a huge potential for the digital product passport, is the UHF tags. They're inherently in a printable process. They're very small and you can fit vast amounts of data on them. And they're unobtrusive. And you can read them with a lot of systems in the supply chain now. And from what I've heard, there's going to be more and more systems at the consumer level that are going to allow us to read them too. It'll give you information on that product that kind of lets you not only know about its material sourcing and whatnot, but I kind of take it a step further because, again, I'm coming at most things thinking about the wireless power aspect of it.
Yeah.
So if we're going to require digital product passports, and UHF tags might be used to do this, to read a UHF tag, you have to have some sort of reader. And any reader is an inherent source of RF energy.
Yeah.
See where I'm going a little bit?
Uh-huh.
So now, for a relatively low cost, you can add basically a V out or voltage out pin on these RFID tags. And now you have wireless power available as well. So there's a ton of opportunity from our perspective on not only the benefits that would come with the digital product passport from a tracking and material, all that information that's stored on it, but now you have the ability to add power to it so that it can do more things. And that's where we kind of come in the RAIN RFID space, is that you've got to have these readers, right? The readers are power. Why aren't we just using the power that's already there to do more stuff? And for stuff on the digital product passports, if it's electronic devices, now you can inherently have a rechargeable device if you're going to have this tag in it anyway. So you can leverage the reader's power as a recharging mechanism. And then on the supply chain side, it's like, well, why aren't you could monitor temperature for this device as it makes its way through your supply chain at the same time. So there's the high level point is that there is power available. We can enable us to use it to do things. And that those things can be extremely broad depending on the use cases example. But given that like the regulations are going to be required, you start thinking about, well, we have to do it anyway. What else can we get out of this that can influence and make our operation smarter, or at the consumer level, make our product cooler or more attractive?
And I mean, I got to think somewhere like you mentioned warehouses a couple of times, but I got to think factory floors are an ideal one for this because you want to instrument your machines, all of your machines, so that you are measuring temperature, you're measuring velocity, you're measuring vibration, you're measuring noise, you're measuring whatever else it is, light, whatever else.
Yeah, and it's like almost twofold, right? Because you're gaining this insight and this data on the product asset, whatever it is itself, right? So as it moves through your supply chain, if you see that we're having trouble because the temperature in this area is getting too high, or this was exposed to a humidity level that's untenable, and that's why we're having problems. So you can optimize your supply chain for the given product that way. Furthermore, you can understand logistics in your own infrastructure about like time spent in different stations. Say you're in a manufacturing environment. And when we do this ourselves, where, hey, it's seems like this item, we're estimating that it's going to stay at this station for 30 seconds on average, and you find out it's there for 4 minutes on average. You have a logistical inefficiency that you didn't know existed, but now, because you have this ability to monitor time as well as these environmental parameters, it influences how you might do things too. So you get the sort of secondary benefit in your supply chain of increasing efficiency. Therefore, the sustainability kind of comes up with that. So you get a lot of benefits from these kind of things. It's just about having access to this data that you can use to influence the product, the operation, and all those kind of things that come with it.
Yeah, yeah, and I mean we've danced around RAIN RFID a little bit. Let's dig into it a bit. Can you talk a little bit about RAIN RFID, how it works, and what makes it so efficient?
So the RAIN RFID Alliance is sort of like this global organization to promote the use of passive UHF. UHF means ultra high frequency radio frequency identification. So it used to be only known as sort of UHF RFID, which is a mouthful. It's all just abbreviations for stuff that's a lot to say. So RAIN is sort of like trying to become this alliance promoting tech the way that other organizations like the NFC Forum or Bluetooth SIG, the Wi-Fi Alliance, like they're basically promoting the use of this technology under sort of the word RAIN, which comes from radio frequency identification. So that's where RAIN is coming from. So it's sort of a link between the radio link to the tag itself and the cloud. So you have this RAIN cloud of data, I think is kind of how they're positioning themselves. And really what they're trying to do is it's already, if you're in the manufacturing space, so RAIN, these tags are used all over the place to track items through a manufacturing supply chain. So when they ran through a certain step, when they moved from location A and they showed up at location B, if they were lost for any reason, it makes it very easy to scan these things. And from a technical perspective, they offer a lot of benefits over some of the other traditional tracking mechanisms that are used in manufacturing, right? Everyone knows barcodes. Yep, you can scan a barcode with a barcode reader. It's a one-to-one technology, right? You scan this one, you scan this one, you scan this one. NFC tags, also used commonly, same thing. It's a one-to-one technology. What's great about the RAIN RFID stuff is that the range on these things is upwards to 10 meters from a standard RFID reader. So you can read these tags in a much bigger space, and it's many to one. So if you have a pallet of goods, you can scan the pallet and get the entire what's on this thing, every single device basically, and know what's there. So from an inventory accounting perspective, right, you have all these things tagged, but you're speeding up logistically how much time it might have taken you to inventory this particular pallet or shelf or whatever it might be. So there's a ton of sort of sustainability reasons why RAIN is kind of interesting, because given the nature of it where you're tracking these things, that's like less wasted material, less you have a better insight into your production sort of materials and sourcing, so you know what's there. So you can eliminate, overstock and things like that. The increased efficiency we kind of touched on a little bit, where it's just time, right? Everything is about speed, and knowing the more data you know, the quicker you can make decisions. By making that more efficient, you have inherent reduced CO2 emissions. Like, I mean, they sort of stack on one another. that way. And then from a security perspective too, these tags can be locked. The data can be made such that it can't be edited. So you have sort of a security element to it as well. That's very interesting. So we talked about asset tracking, but that can be used for asset control as well. Sort of like the way you might see a card at a hotel to gain access to, a room. That's a one-to-one technology. You can do this with UHF RFID the same way, but over a larger range. So you're not having to scan a specific spot. It just knows where a person is at a given time based on them wearing maybe a lanyard with a tag on it or something like that. So you know where folks are. So it's like a real-time location system in that way. All kinds of interesting use cases for it. And I haven't seen it done, but you technically could use it for electronic payments as well, based on that security information. There's a con you could argue there where, NFC might be inherently better because it's near field and you have to kind of actively find and scan this thing. And it can't be like, oh, I'm reading this information 10 meters away or something like that. But again, tons of interesting use cases for these tags.
Okay. And we've got real-time environmental information coming from these tags, things like temperature, humidity, shock, et cetera, et cetera. How are businesses actually using that data today? Have you come across any cool or unexpected applications of this tech that have surprised even you?
Yeah, I'll speak to one very interesting one. But again, I'll say that traditional tags are completely passive. They have no batteries and they're just giving you that asset information. So there's usually an electronic product code that comes with it. And then if there's any kind of memory, is data stored in the memory about where it was made or maybe manufacturing logs, you only start getting the temperature, the light level, the humidity, the shock, the acceleration stuff when you couple that with our technology to enable wireless power in these things, where you're using the power from the reader to do more. So we kind of call that RFID plus or enhanced RFID, where you're not going to get that from a traditional tag. You're only going to get that once you've integrated sort of Powercast's wireless power technology with that tag. So you're taking the traditional tag asset tracking information and adding this extra data on top of it with the Powercast tag. But a very interesting application of it has to do with commercial ovens in a cooking situation. So we designed a tag that was to be used. So when you're doing like batch cooking in a sort of commercial environment, you might have a walk-in oven, and they had these giant trays with like hams on them, and they would roll the rack into the oven, close the doors, and all of it cooks at the same time. So if you're preparing a ton of food at once, that's how it's done. What they wanted to do was basically put a high temperature RFID reader on the ceiling of the oven, and then put tags in every single ham or food dish in there that had temperature sensors built into them, so that they would know what's in the oven and what temperature it's at. So they know when to take things out. It also could tell them where the hot spots or cold spots might be in that oven. And what I really thought was cool about it is that the ovens got very, very hot. So from an electronics and a battery perspective, that's a challenge.
Yeah.
But given we put all of the electronics in the tip of the temperature sensor that would be in the food. So the food only got to 165 F if you're cooking chicken, one of those safe temperatures, which is drastically lower than like the 400 or more that the oven temperature was at. So the electronics were sort of inherently protected by being in the food. But the use case was something I would have never guessed or tried to do, but an awesome use of the asset tracking part of it and the wireless power with temperature reading part of it to enable this kind of very cool application. And once the data gets out, you can do all kinds of stuff on the back end, like, oh, I'm going to send a notification to a phone or whatever about, hey, your stuff's done. So it makes the whole process simpler. You're not checking, open the doors, check it, let all the heat out over and over again to check these things. So that was probably one of the coolest implementations that came to mind that I have been a part of.
Okay. And what would you say are more standard uses then? So for people who are listening who are thinking about their own supply chains, what would be kind of standard use cases?
Yeah. Honestly, like I don't know how you would do a supply chain. At least I play in the electronics world without RAIN RFID. But the number one use case that I come across is the ability to gain temperature data on whatever the thing is throughout its journey. One particular application might be cold chain, where like if you're shipping pharmaceuticals or food products, if something gets above a certain temperature in its journey, there's something negative that happens with the pharma product or food or whatever it might be. And you need to know that you are maintaining that product's integrity throughout its journey. There's a use case right there that we see quite a bit. Sometimes folks just like the additional data to understand environmental factors of their manufacturing facility. So when you're talking about RFID plus, like what we can enable, that is the number one use case we see is I just want to get temperature data along with the asset tracking nature of what I'm already doing. And the cost of implementation is, I don't want to say negligible, but very small, because most of the cost is in the infrastructure of the reader systems. The readers are the power. They're already there. You're just adding a small amount of cost with our chip to interface on the tag side, and off you're getting this additional data while leveraging everything that you've already had in place for your asset tracking anyway. So that's the number one use case that I see in the supply chain, is getting information of the asset itself from the tag, but then if you want more, the temperature part of it from the Powercast wireless power side of it.
And in terms of impact and next steps, what would you say is one thing supply chain leaders should stop doing today if they're serious about sustainability?
That's a good question. Inefficiency in the supply chain is inherent waste and leads to poor sustainability. So given the legislation that I'm aware of that's come out, not just, we talked a little bit about Europe and the digital product passport, but there are things in the US as well about reporting on the sustainability of your supply chain and rules for publicly traded companies that is going to be issued here, where you're going to have to consider that anyway. So the added benefits you get, how much the RAIN RFID can speed up the logistics in your supply chain, you're gaining that advantage right away. And then having the ability to add the RFID plus to that to even gain more insight to influence your decisions. I just see it as it sort of looks like a big step to go from, I'm using barcodes or something like that to getting to RAIN RFID. But given the way that even end consumers are purchasing, they care more about the supply chain, they care about more of the sourcing of the products. Mm-hmm. You're going to have that inherent want and need to do RAIN RFID anyway. So the way I see it is that the benefits come from the speeding up of your operation and the additional information you're gaining to your operation to make better decisions and to clean up your supply chain. So it's cost effective for you in the long run, and it's better for sustainability for basically globally.
And where is all this tech going, do you think? Because I know, for example, I was reading that the Chinese are looking at putting massive solar power plants in space and beaming the power back down to stations on Earth using geosynchronous orbits. That's kind of a long beaming of power. It's not quite where you're headed, I got to think. But work it out for me in terms of Powercast. Where do you see the technology going for yourselves in the next 5 to 10 years?
Awesome question. Thank you for that one. But there's sort of like different stages that you can look out to. You kind of touched on the futuristic space station, Death Star type vibe, which it's possible, don't get me wrong, to do something like that. A lot of folks, the dream would be that charging in general just becomes something you don't think about. Mm-hmm. And I like the idea. What I see happening is sort of a combination. Number one, RFID and the wireless power aspect of that will lead to implementation of wireless recharging in a lot of consumer facing devices, right? So people become sort of inherently understanding of it, just the way that Qi was slowly adopted into things for wireless charging of phones. I think what you will see is that given some of the regulations, you're going to see the addition of wireless charging put into more and more products. So that's the start of things. But I like to think of it as not one technology doing this stuff, but I touched on the 3 different styles that Powercast plays in. I like to think that you're going to have different flavors of wireless charging for different applications, where some of the more high power devices like your laptop or I know you're using like an interface there for your audio program. All that stuff could technically be completely wirelessly powered. So that futuristic idea of no cords on my desk can be inherently true. Your monitor, your keyboard, your mouse, everything you use, your phone, you just set it wherever you want on your desk, and the magnetic resonance style of charging might be charging those devices. Then if you're in an office setting, your building automation system is going to be run completely on wireless power. Now, maybe there are batteries with those things and they're rechargeable, whatever, but the point would be now your building automation system and your IoT devices that are sort of doing those lower power functions, those are now also powered wirelessly. So you're going to have sort of this ecosystem of not having to think so much about keeping devices topped off, because just the inherent nature of what you do every day, they're built into it. So that's kind of like where I see things going, and the path that I see forward is that it slowly gets adopted into things like RAIN RFID tags. And then the added functionality you get out of that is just incorporated naturally into more and more products that people interact with every day. That's kind of the dream on our side and where we see things going. And hopefully we can enable and help be a part of pushing that reality into existence, because I'm tired of carrying 8 chargers with me everywhere I go. I know most people are.
Yeah, no, I got to think, when I look at the streaming services, the Netflix, Apple TV Plus, Amazon Prime, et cetera, when you look at the people in those series, they never plug in their phones to charge them. They wake up in the morning, the phone goes off, they lift it off the bedside table. There's no cable in it. It's not plugged into anything. It's just sitting there on the table, fully charged. So it's always been a bugbear of mine that you never see anyone charging a phone in any series on TV. So I think that you've given them now, I think the likes of Netflix execs and the directors of these series, they're all into your future.
Yeah, like we kind of gave them an out, right? They kind of wrote something that was unbelievable into their story, but it's like, oh no, they were just using wireless charging. That must be
living in the Powercast future.
Yeah.
Okay, left field question for you, Eric. If you could have any person or character, alive or dead, real or fictional, as a champion for wireless power, who would it be and why?
This is a cop-out answer, but I'm going to just Nikola Tesla, basically the guy who came up with it. To have him here now, I mean, this thing would be done already, right? Just the sheer level of genius out of that guy, and just to have him working in the modern day on with what we have available now would be something that would just be so much fun to be around. He might push it even further to the point of being something, crazy, like what you brought up earlier about the solar cells and beaming power down. He might try to do something like that. But I just think that would be interesting guy to pick his brain on how he sees this stuff being used and his ideas for it.
Nice. Yeah, lovely. I like it. Very good. We're coming towards the end of the podcast now, Eric. Is there any question I did not ask you that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to think about?
The only thing I'd touch on a little bit would be, we talked a little bit about futuristic stuff and where the RAIN RFID stuff's heading. I thought it was interesting just looking at what's coming. I know Qualcomm is looking at adding RAIN RFID tag support to mobile phones. So just in the same way that you can read QR codes and you can read NFC tags, the ability to read UHF RFID tags in the mobile phones is very interesting, obviously to Powercast, but also just the fact that if this digital product passport stuff's coming out, the ability to read those items and understand what's in your home, or to enable you to do things about, like, maybe you scan, this is a little far-fetched, but you just scan with your phone everything that's in your fridge, and what's there, what do I need to get, what's the status of the goods in my fridge, things like that. There's already one released by Zebra that has the capability of reading UHF tags. So I think that's the coolest thing that I'm kind of following closely, is because the way that the gateway to the future is like, what's the phone, right? Because everyone's carrying a phone. So whatever gets into that basically is the pathway to getting these things read and used everywhere else. So that's what I follow the most closely and I find to be the most interesting right now.
Nice one. Okay, very good.
Let me ask you, Tom, like, from what you see, you sit in an interesting space in the supply chain world. What about you in the supply chain world? What do you see as the most interesting thing you've observed recently, or exciting things that you've seen either coming down the pipe or even implemented already?
Yeah, well, I'm going to follow your example and cop out, because obviously the most interesting thing that's happened in the supply chain space in the last couple of years has been the rollout of AI and its different implementations and the different forms of AI, not just the LLMs and chat GPTs, but also the likes of machine learning, computer vision, natural language processing, all those kind of things, and the various different ways they've been rolled out and the various different use cases, everything from QC, using computer vision for QC, through to using natural language processing to take in voice commands and, take that and put it directly into ERP systems, using ChatGPT like LLM systems for looking at trends in supplier data, for example, and putting out which suppliers might be able to do X, Y, or Z. It's completely transforming how we deal with supply chain information and convert it into actionable insights, which is the most important part. There's lots of data out there, but there's so much data coming in now, particularly from the likes of the IoT devices we were talking about a minute ago. No one person or even no team of people can analyze that data as it's flowing in real time and pull out exceptions. You need AI to do that for you. And then not just the real-time exceptions, but over time look at trends and see where things are going.
Yeah, I think that's a great point. Even in our own manufacturing processes, we've started to look at using it for yield reasons or for quality control, like you mentioned, where I'm using this system to kind of analyze data taken from maybe an imaging system and like, hey, does this look right? You've run a million down the line and you start to get data to train this thing to be like, this looks bad, this looks good. And you can use that to increase your yield and weed out problems in your production line at the source almost. Just something you, even 5 years ago, never thought was going to be something that could be automated like that. Very cool and exciting.
Yeah. Eric, if people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
Definitely the Powercast website, which is www.powercastco.com. You can find information about the wireless power aspect of our things, information about our team there. And then I'm on LinkedIn. If you have specific questions that you think I might be able to answer for you, I'm not hard to find and I'm happy to talk with anybody.
Great. And I'll put those links as well in the show notes so everyone has access to them. Eric, that's been fascinating. Thanks a million for coming on the podcast today.
Tom, it was a pleasure. Thank you for having me anytime.